The first humans step onto Mars. The dust settles, the sky glows faint red. For a moment, it feels like history has finally arrived. Then something feels wrong, not dramatic, not obvious, just wrong in a quiet, dangerous way. Because Mars is not waiting for humans, it is rejecting them. For years, Mars has been sold as the next home for humanity, a backup planet, second chance, a place where civilization could survive if Earth fails. Governments are planning missions. Private companies are building rockets. The idea sounds bold, it sounds inspiring, it sounds possible, but there is a problem. The real Mars is nothing like the version most people imagine. Decades of data from NASA missions tell a very different story, a darker story, one that rarely makes it into headlines or promotional speeches. The surface of Mars looks empty, silent, almost peaceful. But beneath that silence is a world that is constantly working against human survival, and the most dangerous threats are not the ones you can see. They are invisible, they do not make noise, they do not announce themselves, they do not give warnings, they simply exist, and they kill slowly. Mars does not just lack life, it actively destroys the conditions needed for life. The planet has lost its protective shield. Its atmosphere is thin and unstable. Its environment is extreme beyond anything humans experience on Earth. Every single breath, every drop of water, every degree of warmth must be artificially created and constantly maintained. One small failure is enough. That is all it takes. What makes this even more unsettling is that scientists did not always expect Mars to be this hostile. There was a time when Mars looked promising, ancient riverbeds, mineral evidence of water, signs that billions of years ago, Mars may have had lakes, maybe even oceans. A world that once looked closer to Earth than it does today. But something changed. Mars lost its magnetic field. Its atmosphere began to disappear into space. Solar radiation started hitting the surface without resistance. Water vanished. Temperatures dropped. The planet transformed into something cold, dry, and deadly. And this transformation left behind a world that is not just empty, but dangerous in ways that are still being uncovered. NASA rovers and orbiters have spent years studying this planet. They have drilled into its soil, measured its air, monitored its radiation, and what they found is not encouraging for anyone thinking about living there. Radiation levels that can damage the human body faster than expected. Dust that is not just annoying, but potentially toxic. An atmosphere that cannot support human life for even a few minutes. Temperatures that can freeze equipment and flesh in a very short time. And perhaps most disturbing of all, a level of isolation that no human has ever truly experienced. Mars is millions of kilometers away. Communication takes minutes, not seconds. There is no immediate help, no rescue missions ready to launch, no backup systems beyond what you bring with you. On Earth, problems can be fixed, help can arrive, mistakes can be corrected. On Mars, a mistake can be final, and yet the idea of living on Mars continues to grow. It is presented as the next logical step for humanity, a goal that feels almost inevitable. But very few people fully understand what that actually means. Living on Mars is not like building a city in a desert. It is like trying to survive inside an environment that was never meant for you and never will be. Even the ground beneath your feet can be dangerous. Even the air around you can kill. Even the sunlight can harm you. Every part of the planet presents a challenge, and all of those challenges happen at the same time. This is not a single problem to solve. It is a system of problems, each one capable of ending a human life. And this is where the story becomes even more serious. Because the biggest risk is not the obvious dangers like cold or a lack of oxygen. The biggest risk is the combination of everything. Small stresses adding up, tiny failures stacking together, invisible threats working in the background, the kind of danger that does not feel immediate but becomes unavoidable over time. This is what NASA data has been quietly revealing. Mars is not just difficult, it is relentlessly hostile. In this video, you will discover what NASA has actually found on Mars, not the simplified version, not the optimistic version, the real data, the hidden dangers, the lesser known facts that change how you see this planet completely. You will learn why radiation on Mars is far more dangerous than most people realize, why the dust on the surface could damage both machines and human health, why the atmosphere is not just thin, but actively deadly, and why even the idea of staying alive there depends entirely on fragile technology that can fail at any moment. By the end, you will understand something most people do not. Mars is not just a challenge to conquer, it is a place that challenges the idea of human survival itself. And once you see the full picture, the dream of living on Mars may not feel the same again. Welcome to the channel. If you want to explore the deepest and most surprising truths about space, make sure to subscribe and join us for the journey ahead. There is something on Mars that you will never see. It has no color, no sound, no warning, but it is always there, passing straight through your body. Radiation. On Earth, this threat is mostly invisible because the planet protects you. A powerful magnetic field surrounds Earth like a shield. It pushes away high-energy particles coming from the sun and deep space. On top of that, a thick atmosphere absorbs what gets through. Mars has neither. Its magnetic field is almost completely gone. Scientists believe it disappeared billions of years ago when the planet's core cooled down. Without that shield, space became directly connected to the surface. There is nothing to stop the constant potic of radiation from reaching the ground. This includes solar radiation from the sun and something even more dangerous called cosmic radiation. These are particles traveling close to the speed of light. They come from exploding stars in distant galaxies. When they hit a human body, they do not just pass through harmlessly, they tear through cells, they break DNA. They cause damage that the body cannot always repair. NASA's Curiosity rover has been measuring radiation levels on Mars for years. The data is not comforting. The average radiation exposure on the surface is many times higher than what a human experiences on Earth. In some conditions, a person on Mars could receive the same amount of radiation in a few days that would take months or years on Earth. And this is not just about long missions. Even short exposure is a problem. A human standing on the surface without proper shielding would begin to accumulate damage immediately. There is no safe window, no grace period. The clock starts the moment protection is gone. What makes this more serious is the type of damage radiation causes. It is not always instant. It builds slowly. Cells begin to fail. DNA mutations increase. The risk of cancer rises. The nervous system can be affected. Even cognitive function can decline over time. This is not something you can feel happening. There is no pain at first, no clear signal that something is wrong, and that is what makes it dangerous, because by the time effects appear, the damage is already done. Even spacesuits are not enough on their own. Standard materials cannot fully block high-energy cosmic rays. To stay safe, humans would need thick shielding. This could mean living underground, inside caves, or beneath layers of Martian soil, but that creates another problem. Every movement outside becomes a risk. Every step on the surface increases exposure. Every delay or failure in protection systems becomes critical. Even solar storms add another layer of danger. The sun can release massive bursts of radiation without warning. On Earth, these events are mostly deflected. On Mars, they hit directly. A strong solar storm could expose astronauts to deadly radiation levels in a short time, and there's nowhere to hide quickly. Shelters must be built in advance. Systems must work perfectly. Timing must be exact, because on Mars, the threat does not come from one direction. It comes from everywhere, above, around, and straight through you. And while this invisible force continues its silent attack, another danger waits on the surface, one that looks harmless at first but carries its own deadly secret. There is a danger on Mars that never rests. It does not wait for mistakes. It does not depend on weather. It is always present, moving silently through the air and the ground and the human body. Radiation. On Earth, this threat is kept under control. A strong magnetic field surrounds the planet and deflects most of the harmful particles coming from space. The atmosphere acts as a second layer of defense. Together, they reduce radiation to levels that life can handle. Mars lost that protection a long time ago. Its magnetic field collapsed billions of years in the past. Scientists believe the planet's core cooled and stopped generating the field. Without it, the surface was left exposed. The atmosphere began to thin out as solar wind stripped it away. What remained was a world open to space. Now, radiation from the sun reaches the surface without resistance. Even more dangerous are cosmic rays. These particles travel across the universe at extreme speeds. They come from violent events like supernova explosions. When they strike a human body, they do not stop at the skin. They pass through, they collide with molecules inside cells, they break chemical bonds, they damage DNA directly. Sometimes the body repairs this damage, sometimes it fails. That failure is where the real danger begins. NASA's Curiosity rover has been recording radiation levels on Mars since it landed. The data shows a constant stream of exposure far above what humans experience on Earth. A person on Mars would receive in 1 year what might take several years on Earth. And this is during relatively calm conditions. During solar events, radiation levels can spike sharply. A burst from the sun can flood the surface with high-energy particles. On Earth, this would be mostly absorbed or deflected. On Mars, it arrives almost untouched. There is no natural shield. Only technology stands between survival and exposure. Even inside a habitat, protection is limited. Walls must be thick. Materials must be carefully chosen. Every gap, every weak point allows radiation to pass through. Over time, even small amounts add up. This is not a single event. It is a continuous process. Cells are hit again and again. Damage accumulates. The risk of cancer rises steadily. The nervous system can also be affected. Some studies suggest long-term exposure could impact memory and decision-making. That creates another problem. Judgment may decline in an environment where every decision matters. Even outside activities become dangerous in ways that are easy to overlook. A simple task on the surface. C increases exposure. A delay in returning to shelter increases it further. A damaged suit or a failed system can turn a routine mission into a life-threatening situation within hours. And the human body gives no immediate warning. There is no sudden pain, no clear signal to stop. The danger builds quietly beneath the surface until it reaches a point where it can no longer be ignored. Because on Mars, the threat is not just the environment around you. Because on Mars, the threat is not just the environment around you. It is something passing through you, changing you one particle at a time. And while this invisible force works in silence, the planet holds another danger that seems harmless at first glance. A fine layer covering the ground, drifting through the air, waiting to be disturbed. The air on Mars looks calm. It moves slowly across the surface. Thin clouds drift in the sky. Dust lifts and settles without urgency. At a distance, it almost feels familiar. But that air is not meant for you. It is over 95% carbon dioxide. Oxygen is almost non-existent. On Earth, the body depends on oxygen in every second. It fuels the brain. It keeps organs alive. Remove it, and the body begins to fail within moments. On Mars, there's nothing to breathe, and the problem goes deeper than just oxygen. The atmosphere itself is extremely thin. Pressure on Mars is less than 1% of what exists on Earth. This changes how the human body behaves in a way that is difficult to survive. When pressure drops that low, oxygen cannot stay dissolved in the blood. Even if oxygen were present, the body would struggle to use it. The balance that keeps cells alive breaks down almost immediately. Exposure without protection leads to rapid unconsciousness. Within seconds, the body begins to react. Air inside the lungs expands. Moisture on the skin starts to evaporate. Saliva can begin to boil at normal body temperature, not because of T, but because pressure is too low to keep it stable. This is not a slow process, it happens fast. The brain is one of the first to be affected. Without oxygen, it loses function quickly. Vision fades, awareness disappears. There is no time to think clearly, no time to react. And even if a person is rescued within a short window, damage may already be done. The body is not built for this environment. Even inside a spacesuit, survival is not guaranteed without perfect conditions. The suit must maintain pressure at all times. It must deliver oxygen at the correct levels. It must remove carbon dioxide continuously. A small failure in any part of this system can become deadly. A tiny leak is enough. Pressure begins to drop. Oxygen levels fall. The process starts again, quietly and quickly. Habitats on Mars face the same challenge. They must act like artificial bubbles of Earth. Every wall must hold pressure. Every seal must remain intact. Air systems must run without interruption. There is no natural support from the environment outside, and Mars does not make this easy. Temperature changes cause materials to expand and contract. Dust can interfere with seals. Micrometeorites can strike surfaces at high speed. Over time, even strong structures can weaken. This creates a constant battle, not against a sudden event, but against slow failure. Air can escape in ways that are hard to detect at first. Pressure can drop gradually. Systems must monitor every detail. Repairs must happen immediately. There is no margin for delay, because outside those walls there is nothing to support life, just a thin, cold layer of gas that cannot sustain a single breath. And even inside, the air must be manufactured, recycled, and protected every second. There is no backup from nature, only machines, only systems, only control. And while the struggle to breathe continues behind sealed walls, another threat waits outside, covering the ground and filling the sky. It looks simple, it feels harmless at first, but it carries a danger that spreads into everything it touches. At first it looks harmless, a thin layer covering the ground. Soft red particles that move gently with the wind. It feels like dust you could brush away with your hand. But on Mars, this dust is not ordinary. Each grain is incredibly fine. Much smaller than sand on Earth, it forms through billions of years of erosion without water to smooth it out. That means the particles remain jagged, sharp at a microscopic level. Like tiny fragments of broken glass, when this dust touches the surface, it does not just sit there. It clings, it sticks to suits, it coats equipment, it settles into joints, seals, and moving parts. Static electricity makes it even worse. The particles charge easily and grip onto materials in a way that is difficult to remove. NASA missions have struggled with this problem for years. Rovers on Mars slowly lose efficiency as dust builds up. Solar panels become covered, instruments degrade, mechanical parts wear down faster than expected, and this is with machines designed for the environment. For humans, the risk is far greater. Martian dust is not just abrasive. It may also be toxic. Scientists have detected chemicals called perchlorates in the soil. These compounds can interfere with the human body. They can disrupt thyroid function. They can affect metabolism. In large amounts, they become dangerous. If this dust enters a habitat, it becomes a serious problem. It can spread through the air, settle on surfaces, contaminate water systems. Cleaning it completely is almost impossible. Over time, small exposure could build into something harmful. Even suits cannot fully protect against it. Dust can attach to the outer layers and travel inside when astronauts return. Every ant, what becomes a potential contamination event? But the real danger appears when the dust begins to move. Mars is known for its dust storms. At first they seem small, local winds lifting particles into the air, limited in size, temporary, then they grow. Storms can expand across regions, then across continents, and sometimes they spread across the entire planet. A global dust storm can cover Mars in a thick haze that blocks sunlight for weeks. This has already happened. During one such storm, NASA lost contact with the Opportunity rover. Its solar panels were covered, power levels dropped, the machine could not recharge. It slowly shut down and never recovered. For human missions, this is not just a technical failure. It is a survival threat. Solar power becomes unreliable. Energy systems weaken, temperatures inside habitats become harder to control. Life support systems depend on consistent power. Without it, every function begins to fail. Visibility also drops. Navigation becomes difficult. Communication can be affected. Moving outside becomes dangerous, and the dust does not settle quickly. It lingers in the atmosphere, circles the planet, returns again and again. This creates a cycle. Dust builds up, systems weaken, cleaning becomes harder, exposure increases, a slow breakdown that affects everything at once, because on Mars, the ground beneath your feet is not stable, it is active, it moves. It spreads, it invades, and while this fine layer continues to cover every surface, another force works silently in the background, one that does not drift or settle but freezes everything it touches. The cold on Mars is not just uncomfortable, it is constant. It surrounds everything, it seeps into every surface, every material, every system. The average temperature is around minus 60 degrees Celsius. That is colder than the coldest places on Earth most people will ever experience, and that is just the average. At night, it gets much worse. Temperatures can drop below minus 100 degrees Celsius. In some regions, it falls even lower. There's no thick atmosphere to hold heat. No oceans to store energy. When the sun disappears, warmth vanishes almost instantly. This creates a world where heat is never stable. Every structure, every machine, every human depends on artificial warmth. Without it, survival is measured in minutes. The human body loses heat quickly in extreme cold. Blood flow changes, muscles stiffen, reaction time slows down. Eventually, vital organs begin to fail. On Mars, this process is faster because the environment offers no resistance. Even inside a suit, heat must be actively generated and controlled. Systems must circulate warmth around the body. If that system fails, the cold begins to take over immediately. There is no buffer, no gradual adjustment, just rapid loss. The cold also affects something even more critical. Water on Mars, liquid water cannot exist easily on the surface. The low pressure and freezing temperatures force it into ice or vapor. This means any exposed moisture behaves unpredictably. It can freeze solid or disappear into the air almost instantly. For humans, this creates constant risk. Any exposed skin loses moisture rapidly. Equipment that relies on fluids can freeze. Systems that manage water must be perfectly insulated and controlled. Even small failures become dangerous. Pipes can freeze and crack. Seals can become brittle. Materials can shrink and weaken. Over time, repeated exposure to extreme cold causes wear that is difficult to predict. NASA has seen this effect on robotic missions. Components that work perfectly at the start begin to degrade. Batteries lose efficiency in low temperatures. Mechanical parts become less reliable. Electronics must be carefully heated to function. And for human missions, this is not just a technical issue, it is a matter of survival. Every habitat must maintain a stable internal temperature at all times. Heating systems must run continuously. Energy supply must never stop. If power drops, temperature inside begins to fall, and it falls fast. Within a short time, conditions inside can become dangerous. Water systems freeze, air systems struggle, human bodies begin to lose heat. There's no natural recovery. Everything depends on control. Even movement outside becomes a challenge. The ground is cold enough to affect mobility. Equipment becomes harder to handle. Simple tasks take longer. Exposure time increases risk because on Mars, the cold is not a temporary condition. It is the default state. A constant pressure on every system, every decision, every second. And while this frozen environment continues to test the limits of survival, another challenge begins to grow quietly in the background. One that does not attack the body, but the mind itself. Distance on Mars is not just measured in kilometers, it is measured in time, silence, and delay. Mars is millions of kilometers away from Earth. At its closest, the gap is still vast. At its farthest, the distance becomes almost unimaginable. Signals traveling at the speed of light still take time to cross that space. Communication delay can reach more than 20 minutes. One way, that means a simple message takes over 40 minutes for a full exchange. A question sent from Mars, a reply sent back from Earth. Nearly an hour passes before a complete conversation happens. There is no real-time contact, no instant advice, no immediate support. Every decision on Mars must be made alone. In an emergency, this delay becomes critical. A system failure, a medical issue,
A sudden problem outside the habitat, there is no way to call for help and receive instant guidance. By
the time a message reaches Earth, the situation may have already changed or ended. This forces astronauts to operate with complete independence. Training must prepare them for every possible scenario. But not every situation can be predicted. Unknown problems can appear without warning, and when they do, there is no backup, no rescue team waiting nearby, no quick return home. Even traveling back to Earth is not simple. Launch windows open only at specific times. Missing that window means waiting months for the next opportunity. During that time, the crew remains on Mars dealing with whatever challenges arise. This creates a different kind of pressure. Not physical, but mental. Isolation becomes constant. The crew is separated from everyone they know. Family, friends, society, all reduced to delayed messages on a screen. There is no direct human connection outside this small group present on the mission, and that group is also under stress. Confined spaces make it harder. Habitats must remain sealed and controlled. Movement is limited. Privacy is minimal. The same environment repeats every day. The same faces, the same routines. Over time, this affects the mind. Studies on Earth have already shown this. Researchers simulate Mars missions in isolated environments. Crews spend months in confined habitats with delayed communication. Even in these controlled conditions, psychological strain appears, mood changes, irritability increases, focus begins to drop, small disagreements can grow into serious conflicts, motivation can decline, a sense of detachment can develop. On Mars, these effects could be stronger because the isolation is real, the distance is real, and the distance is real. Every action carries weight. Every action carries weight. Every task matters. A single mistake can have serious consequences. There is no margin for error in a place where survival depends on precision, this constant A. Awareness creates tension, not always visible, but always present. Sleep can be affected, stress can build. Slowly, the mind begins to carry the burden of responsibility every hour of every day, and there is no escape from it. No stepping outside for fresh air, no leaving the environment behind. Only the same controlled space, surrounded by a planet that offers no comfort. Because on Mars, survival is not just about protecting the body. It is about holding the mind together under conditions it was never designed to handle. And while this pressure continues to build inside, another challenge waits beyond the walls. One that seems essential for life, yet remains just out of reach. Water once shaped Mars. There is clear evidence carved into the surface. Dry river channels stretch across the landscape. Valleys cut deep into rock. Minerals formed only in the presence of water lie scattered across the ground. Billions of years ago, Mars was not the frozen desert it is today. It had flowing water. It had lakes. Some scientists believe it even had vast oceans, but that world is gone. Today, liquid water is almost impossible to find on the surface. The pressure is too low, the temperature is too cold. Water cannot remain stable in liquid form. It either freezes into ice or turns into vapor and disappears into the thin atmosphere. This creates a strange reality. Water exists on Mars, but not in a way that humans can easily use. Most of it is locked away, frozen beneath the surface, trapped in polar ice caps, hidden in forms that require effort and energy to access. Even when it is present, it is not always safe. NASA has detected signs of briny flows. These are small streaks that appear on slopes during warmer seasons. They suggest the presence of salty liquid water. But this water is not clean. It contains high concentrations of salts and chemicals. Among them are perchlorate. These chemicals lower the freezing point of water, allowing it to remain liquid in extreme cold. But they also make the water toxic for human use. Consuming or even prolonged exposure to perchlorates can disrupt the body in harmful ways. This means that even when water is found, it cannot simply be collected and used. It must be processed, purified, handled with extreme care, and that process is not simple. Extracting water from Martian soil requires advanced systems. Machines must heat the ground to release trapped ice. Vapor must be captured and condensed. Filtration systems must remove contaminants. Each step requires energy, precision, and constant maintenance. A failure in any part of this chain can stop the entire supply. And water is not optional. It is needed for drinking, for food production, for oxygen generation, for temperature control. Every part of survival depends on it. This creates a fragile system, one that must work without interruption. Even storage becomes a challenge. Water must be kept from freezing. Containers must handle pressure changes. Pipes must stay insulated. A small leak or crack can lead to loss that is difficult to recover. There is no natural backup, no rivers to draw from, no rain to replenish supplies. Everything must be created, managed, and protected by technology. And that technology must operate perfectly in one of the harshest environments known. Because on Mars, water is not just scarce, it is uncertain. It exists in forms that are difficult to reach, dangerous to use, and dependent on systems that can fail. And when those systems are pushed to their limits, the line between survival and disaster becomes thinner than ever. Mars is not just a difficult place to live, it is a place that constantly works against life. Every basic human need becomes a problem to solve. Air must be created, water must be extracted, heat must be maintained, protection must be perfect. Nothing comes naturally. Nothing is guaranteed. What NASA has revealed over decades is clear. Mars is not waiting for humans to settle. It is testing every limit of human survival at the same time. Radiation moves silently through the body. The air cannot be breathed. Dust invades everything. The cold never leaves. Isolation presses on the mind. Water exists, but just out of reach. Each challenge alone is serious. Together, they create an environment where survival depends entirely on technology that cannot fail. And that is the truth most people do not see. Living on Mars is not about building a new home. It is about maintaining a fragile system in a place that was never meant to support life. One small mistake can lead to a chain reaction. One failure can spread across every system. There is no natural safety net, no second chances built into the environment. Yet the dream continues. Humanity still looks at Mars as the next step, a place to expand, a place to survive beyond Earth, and maybe one day that dream will become real. But it will not be easy, it will not be safe, and it will demand more from humans than any environment ever has. So the question is no longer just about reaching Mars. It is about staying there. If you found this journey into the reality of Mars interesting, take a moment to like the video and subscribe to the channel for more deep dives into space, science, and the hidden truths of our universe. Because the more we learn, the more we realize how extreme the universe truly is.